Hi everyone, welcome back to the channel, and today we're going to solve Leetcode daily challenge problem number 647, palindromic substrings. So it is tagged as a medium level problem, and we'll first check out the problem statement, then we'll look into the approach which you're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it is given that we'll get a string S and we have to return the number of palindromic substrings in it. So palindrome is basically are the combinations, I would say, which reads same backward and forward. Okay, so it can be ABA, okay, BAB, all these words or all these strings who reads same backward and forward are called palindrome. And substring, as you know, is a contiguous sequence of characters within the string. So we'll have to find out the number of palindromic substrings from the string. For example, in this case, they have given ABC, and number of palindromic substring is 3 because individual length 1 substrings will only be applicable. But in example number 2, there are 6 palindromic substrings possible, and they are like individual elements, then with length 2 and then with length 3. So let's check out how we can solve this question. Okay, so what I'm gonna do, I'm gonna use pointer approach to solve this question. We can also use dynamic programming, but what I will be doing is, so I'll run a loop from 0 to n, okay, covering all the characters one by one. And the core logic behind that is, for example, my pointer is at this index. Okay, now what I'll do, one more thing which I would like to mention over here is we'll have to write logic for two parts I should say. First one for odd length, okay, and second for even length. And the base logic will be same, it will be just about the initialization. Okay, so for example, what I'll do, I'll run a loop with each index. Okay, for let's assume that my current index is pointing to A. Okay, now what I will do, I will decrement my left pointer and increment my right pointer. This is my left, this is my right. Okay, I initialize both the pointers with the same index itself. So initially we had length is equals to 1. Okay, when both the pointers were pointing to the same index or same character. Now we have incremented on both the ends, so now length has become what, 3. Now if we'll increment both the pointers, like we'll expand both the pointers, it will be 5. So as you can see, like we are following all the odd lengths here in this case. Okay, so what was the condition of that, like what were we doing? L and R pointers were initialized to I, both were initialized to I, and that's when we were getting all the odd lengths. Okay, now the logic here, the logic behind this is, let's say your individual element will always be a palindrome, because of course, like A is A whether you read from forward or backward. Now if you expand your boundaries, okay, these are your boundaries, right? This was your initial boundary. Now we are expanding it, and if we get the same character on both the sides, can we say that okay, this is also a palindrome, right? So this is the core logic behind it, that we have a fixed position and we are trying to expand the boundaries as much as we can. Okay, so this will be the core logic, and for even length, as we said, the only thing which will change will be the initial length which we are gonna use. So for example, for odd lengths, we pointed both our uh, pointers to the same location or to the same index, right? But for odd or for even lengths, what I will do, let's add one more A over here so it will be more clear. For even lengths, I'll take pointers to I. Let's say this is I, and the right pointer will point to I plus 1. So the difference is in the initialization, that's it. the logic remains the same, that we are trying to expand our boundaries as much as we can. So now if we have this, for example, if you see, now our current length is 2. Current length is 2. We will expand our boundaries on both in both the directions. The length will become 4, 6, and so on and so forth. So using these two initializations, we will cover all the substrings possible, and we can check if they are palindromes or not. Okay, so this is the core logic. Let's check out the code. Okay, so this is the code to to do the same operations which we just discussed in the explanation. So I'm using a variable called result to store the number of palindromes possible, and as I said, I'll be running a loop across all the index, covering all the index, I should say. Okay, now for odd length, if you see, we have initialized both left pointer and right pointer to same index. Okay, and this logic is basically to check if we are getting out of bound or not. Okay, so if it is within the bound, we are checking if the character at both the indexes are same. If yes, then we will increment our result variable with 1, and expand our boundaries by subtracting 1 from the left point and adding 1 in the right pointer. And for even length, what we have done, we have taken L as our current index and R as our I plus 1. Okay, and again we are checking if the pointers are within bound. If yes, we are checking if when expanded, if the characters are same or not. If yes, then we will add in the result variable, we'll add 1 in the result variable, and again expand the boundaries. So this is the logic. Let's check out the test cases, and at the end we are just simply returning the result variable. So the test case got clear. Let's submit for further evaluation now. And yeah, as you can see, the solution got accepted, and also like we have performed decent. So yeah, this was the solution, guys. Thanks everyone for watching other videos. Stay tuned for the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.